students. Welcome to the another session, and this is the working session on chapter called Lines and Planes. Here comes the first question. Read the question carefully. If a line passing through 3 points meet XYZ axis in A, B, C respectively, what is the A value? Means they are talking about the x-intercept. They are talking about x-intercept. So you have to find the plane equation passing through these 3 points. Okay. So any plane passing through 3 points will be det of x minus 2, y minus 3, z minus 0. Means x minus x1, y minus y1, z minus z1. In the next line, I need this one. So x2 minus x1, 0 minus 2. You will be getting minus 2. Minus 5 minus 3, minus 8. 2 minus of 0 is 2. Next one is this one. Minus 2 minus 2 is minus 4. 0 minus 3. 3 minus 0, 3 is equal to 0. Actually, since I require the x-intercept, that means y is equal to z is equal to 0. We need to substitute in the plane. I will. So here it will be x minus 2 minus 3, 0 minus 2 minus 8 plus 2 minus 4 minus 3 plus 3. I'm just substituting x is equal to y is equal to z is equal to 0. So the value will be x minus 2 into minus 24 plus 6 is equal to 18. Minus 24 plus 6. So it's with minus. Minus 3 is there. Anyway, when you are taking this minus of minus, we need to take plus 3 times of minus 6 plus 8. This is minus 6 plus 8. So plus 2. 0 to anyway value will be equal to 0. Okay. So answer will be equal to x minus 2 is equal to, this is 6 by 8. It is equal to 1 by 3. So the x-intercept is 7 by 3. So x-intercept 7 by 3. So value will be equal to 7 by 3 comma 0 comma 0 is the point. I need to find the normal of these 3 points. So if this is a plane, one way of doing is finding the plane equation. Another way is find the drs of two lines and find the direct cross product of that. 3 minus 0, 3, 0 minus 1, minus 1, 2 minus of 2, 0. Next, 4 minus 0, 4, 5 minus 1, 4, 0 minus 2. You will be getting minus 2. So, drs of this line will be 2 comma 2 comma minus 1. Cross product of this I, j, k, 3 minus 1, 2, 2 minus 1. So I into 1 minus 0 is 1. J, actually minus sign will be there. Minus 3. So plus 3 because minus of minus. And plus k into 6 plus 2, 8k. Okay. So this is the drs will be 1 comma 3 comma 8 divide with the root over a square plus b square plus c square, 74. So the answer is 12 by root 74. Sum of the DCs. A plane containing two lines whose DRs and passes through, if this plane also passing through this, the value of K. So simply you can find the plane containing this and you go for this. How is this? This is x minus 3, y plus 1, z minus 4. And you write minus 1, 2, 1 and 1, 3, 2. Now this plane passing through this point. You substitute here 2. So minus 1, 2 and k minus 4. Minus 1, 2, 1, 1, 3, 2 must be equal to 0. You solve this equation to get the value of k. Next question is the Cartesian equation of the plane parallel to this, distance of 2 units from it. So this plane 2x plus 3y minus 4z is equal to 1. So any plane parallel to this one is 2x plus 3y minus 4z is equal to something. So the distance between these 2 points is 2 units. So the formula is modulus of p minus 1 by root over plus p square is equal to how much units? So p is equal to 1 plus or minus root 29 is the answer. Okay. So 2x plus 3y plus minus 4z is equal to 1 plus or minus 2 root 29. If the Cartesian equation of the plane passing through 1 comma 2 comma 1 parallel to vectors this and this is this, what is this value? So equation of the plane passing through this one parallel to these two lines. There are the ways of doing. One is the determinant form, that is simply x minus 1, y minus 2, z minus 1, and you write 2, 3, 1, minus 1, 2, minus 3 is equal to 0. This is, or you just find the cross product of this and you can go. Or another way of doing is this is perpendicular to this one is perpendicular to this one, and satisfy this one. From so you can find the ABC values. Okay. So it is up to you which is comfortable. Either this one or cross product of this. To do the actually AB ratio will come. So equal to so cross product if I want to take IJ. So we have 2 minus 1, 2, minus 3. So I value minus 9, minus 2, minus 11. J value minus 1, minus plus 5. K value will be 4 plus 3, 7. Okay. R you get. So now this, so minus 11 into x minus plus 5 into y plus into z minus 1 is equal to same thing. X minus 11, y minus into minus 6 plus 1, minus of plus. So here what happened? Minus 11x, 5y plus 7z is equal to, this is 11 minus 10 minus 7. So 11 minus 10 minus 7. So it is equal to 6. But I need 1 is there. It is minus 11 by 6 plus 5 by 6 plus 7 by 6 into 18. So this value is equal to 1, 3. So You are going to get the answer as 3. Okay. Next question is equation of the plane passing through the intersection of two planes perpendicular. So any plane passing intersection of two planes is pi 1 plus lambda pi 2 is equal to 0. But this plane is perpendicular to pi 3. So pi 1 pi 2 plus lambda into pi 2 is equal to 0. So you need to find the lambda the dot product. So lambda is equal to minus pi 1 pi 2 means that normal dot product. Okay, 2 pi 3. So this is equal to minus 2 6 plus 8. 2 plus 6. Okay, we will be getting 2 plus 16 by dot 1 minus 1 minus 4 is equal to minus 4 is equal to 4. Okay, so this one plus 4 times of this one is going to be our answer. So 2x, 6x, and next you continue with this one. Otherwise, one way you can go just normal verification where each of the plane, if you have 2, 3 planes perpendicular, then issue comes. So it is simple 2x, 6y plus 4z plus 7 plus 4 times of x minus y minus 2 plus 2. So this is 6x, 2y. Okay, next minus 4z minus 15 is equal to 0. Is there any answer? Is there? Yes, we have that answer. The next question is the combined equation of two planes were given and we are supposed to find out the okay angle between them, and one of the plane is parallel to x plus 2y minus 2z is equal to 5. So this is the plane, pair of planes actually. So what you need to do is you need to take this portion and split into two parts. So this is 2x square minus 6y square minus 12z square. This is one plane is parallel to this one. So I'm writing just planes passing through the R is in only this. So into here what is the thing? Plus all these values are there. 2x square is there. So if I write this plane is ax plus by plus cz plus some constant to reduce this one. Here what happened? A1, A2, B1, B2, C1, C2. So here this value will be A should be equal to 2. So this plane should be 2x. Next 2b is equal to so minus 3y and here plus 6z. So one plane will be x plus 2y minus 2z plus k is equal to 0. Another plane will be 2x minus 3y plus 6z plus L is equal to 0. Angle between these two, cos theta is equal to A1 A2 plus B1 B2 plus C1 C2 by square root of A1 square plus B1 square plus C1 square into root over here. This is 49. Answer will be equals to 18 minus 2. So 16 by this is 3, this is 7, 21. So answer will be cos inverse 16 by 21. So it is simply you need to split the given combined equation of planes into two separate. Next question is a variable plane is at a distance of 6 units from the origin. It meets the coordinate axis ABC, the equation of the locus of the centroid of the triangle. So I will write that equation as Lx plus My plus Nz is equal to 6, where L, M, N are directional cosines. So directional cosine means L square plus M square plus N square is equal to 1. So your x-intercept is 6 by L comma 0 comma 0. Y-intercept is 0 comma 6 by M comma 0. And Z meeting at C will be 0 comma 0 comma 6 by M. If x comma y comma z is centroid, 3x comma 3y comma 3z is equal to, this is 6 by L comma 6 by M comma 6 by N. So from here L square plus M square plus N square, you take that part into the consideration. So you'll get x power minus 2 plus y power minus 2 plus z power minus 2 is equal to 1 by 4. A is the answer. And the next question is image of the point with respect to the plane this. So if this is a plane, I need to find the image of 5 comma 2 comma 6. So what is the image? So it is h comma k comma l. So it will be h minus 5 by 1 is equal to k minus 2 by 1 is equal to L minus 6 by 1 is equal minus 2 times of, you need to substitute this one, 5 plus 2 plus 6 minus 9 by a square plus b square plus c square. Yes, 7 plus 6, 13. So value will be equals to, this value will be equals to how much? 4. So it is equal to minus 8 by 3. So h is equal to 5 minus 8 by 3. So h is equal to 7 by 3. K is equal to 2 minus 8 by 3. So answer will be equal to minus 2 by 3. This is 7 by 3. And L is equal to 6 minus 8 by 3, 10 by 3. So the answer is C. Option is the right one. A plane meets the coordinate axis PQR. Centroid is this one. If this is the centroid, the point P will be 3 comma 0 comma 0 and Q will be equal to 0 comma 3 by 2 comma 0 and R is 0 comma 0 comma 1. What is the plane equation? X by 3 plus y by 3 by 2 is equal to, sorry, plus z by 1 is equal to 1. So this value will be equal to x plus 2y plus 3z is equal to 3 is the answer. ABC are the intercepts made by the plane passing through the point 1, 2, 3 parallel to this one on XYZ axis respectively are. So any plane parallel to this one and passing through this point, it will be 3x plus 4y minus 5z. So coming to the next question, if the equation of the plane, if the equation of the plane is given at a distance of 1 by 3 units from the origin perpendicular to the lines this. So these are the dr of the normal of the plane. So dr, so this value x plus, so drs will be x 1 by 3x and 2 by 3 into y plus 2 by 3 into z is equal to how much distance? 1 by 3 units. This is a, I'm converting DCRs into DCs. So that what happened, I can write that direct value. So this is x plus 2y plus 2z minus 1 is equal to 0. So what is the plane equal? PQR. So the answer is equal to 3 root over 4 plus 4 plus 1. Next question is x-intercept of the plane passing through this is 5 by 2. And perpendicular distance from origin to the plane is this one. If the y-intercept of plane pi is negative and z-intercept is positive, what is the y-intercept is? So plane is passing through this one, x-intercept is this one, and perpendicular distance from plane to this one is okay. So how I can write where I need to start? It's a question mark. Okay. So what I'll do is x by 2 by 5 x into plus y by b plus z by c is equal to 1. So this is 5x by 2 plus y by b plus z by c is equal to 1. Two unknowns are there. First one is passing through 5 comma 1 comma 1 comma 5 by 2 plus 1 by b plus 1 by c is equal to 1. Or 1 by b plus 1 by c is equal to minus 3 by 2. This is one condition. Perpendicular distance from origin to this plane 5 by 7 is equal to 1 by square root of b square 25 by 4 plus 1 by b square plus 1 by c square. Or 49, squaring and writing the reciprocal, 49 by 25 is equal to 25 by 4 plus 1 by b square plus 1 by c square. Okay. So here 1 by b square plus 1 by c square is equal to 49 4 are 196. Okay. So just a minute. I'm redoing this question. So x-intercept of the plane is this. Perpendicular distance from the origin is this. Y-intercept is negative. So only these are the three conditions are given. Okay. So how we are going to deal with this? So any plane is a into x minus 1 plus b into y minus 1 plus c into z minus 1 is equal to 0. So this is equation is ax plus by plus cz is equal to a plus b plus c. So x-intercept is a plus b plus c by a is equal to 5 by 2. So 2 times of b plus c is equal to 3. Right? What is the perpendicular distance? 5 by 7 is equal to a plus b plus c modulus by root over a square plus b square plus c square. Okay. Now you carefully observe what I exactly require y-intercept. What is the y-intercept? I need a plus b plus c by b. I need this. Okay. So this value is equal to a plus b plus c is equal to 5 by 2. 5 by 7 is equal to 5 by 5a by 2 by root over a square plus b square plus c square. 5 cancel. Okay. So 7a is equal to 2 into root over a square plus b square plus c square. This equation and this equation you solve and you'll be getting minus 5 by 3 as b value. A ray of light passes through the point 1, 2, 3, and strikes the plane. So the plane is here and a line from 1 comma 2 comma 3 hits this plane at B. Now reflection passes through C. So where is this point? Reflection passes through C. What is the OB? So I need B point here. So simply what happened? No, if you find the image of C, so it will be passes through this one. So you need to find the reflection of C with respect to this point. So reflection of this one is h minus 3 by 1 is equal to k minus 5 by 1 is equal to z minus 9 by 1 is equal to minus 2 times of 3 plus 5 plus 9. Okay, so 12, 12 cancel. Its value will be 5 by a square plus b square plus c square. So that reflection point is 3 minus 10 by 3, 5 minus 10 by 3, 9 minus 10 by 3. So the point is minus 1 by 3, 5 by 3, 17 by 3. So you join these two and where it is intersecting this line, you will be getting this point. You'll be getting this point. So directly you'll get the answer. So once you get, so the line equation is x minus 1 by y minus 2 by z minus 3 by. So what is the dr? 1 minus of 1 minus 3 is equal to this one. 2 minus of 5 by 3, 6. So 1 by 3. 3 minus of 17 by 3 is minus 8 by 3. So drs are 4, 1 minus 8. So is equal to t. Point on this plane, you'll get the t value. Find the distance. Okay? Right. Next question is, if the distance of the plane from the point measured along a line parallel to this. So what you do is, this is the plane. I have a point here, 1 comma minus 1 comma 1. Actually, we can find the perpendicular distance. No, I'm not expecting that one. I'm expecting this distance whose drs are 231. So this is will be 231 by root 14. Yes. So I will write the line equation as x minus 1 by 2 by root 14 is equal to y minus 3 by 3 by root 14 is equal to, okay, point is 1 comma plus 1 and z minus 1 by 1 by root 14 is equal to t. So any point will be 1 plus 2t by root 14 minus 1 plus 3t by root 14, 1 plus t by root 14. So this point lies on 3x plus 4y plus 5z plus 19 is equal to 0. So whatever the t comes, because these are the directional cosines, t is the distance straight away you will be getting. Okay. So if you want to write, just you think what is the value you are going to get. So when I substitute here, 3 minus 4 plus 5. So what is this one? 8 minus 4. 8 minus 4, 4. 4 plus 19, 23 plus. If I take t out, this is 6 plus 12 plus 5. 18, 23 by root 14. Okay. Is equal to 0. So t is equal to root 14. T is equal to root 14 because t will be minus, you'll get here, you can take plus or minus. So the distance will be equal to that value. Two lines have a common point. So when two lines are common point, first thing, Look at, they are not parallel. Simply you can write det of 1 minus 3, that is, or 3 minus 1, 2, k minus of minus 1, k plus 1, 0 minus of minus 1, 2, 3, 4, 1, 2, 1 must be equal to 0. Okay? R is equal to T. So Z is equal to T and K is equal. You just substitute the things. Okay? So this is the better thing to find and the value will be equal to 9 by 2. Next question is, if the foot of perpendicular drawn from the origin to this one, then the point on that plane. So I need this plane 0, 0, 0. Foot of the perpendicular is 1, 2, 3. So drs of this normal will be 1, 2, 3 only. So the plane equation is x plus 2y plus 3z, because dr passing through 1, 2, 3. 1 plus 4 plus 9 is equal to 14. So which of these points will satisfy? 3 plus 4 plus 3? No. Next, 7 plus 4 plus 3? Yes. This is the answer. Next question is, the equation of the plane through 4 comma 4 comma 0 perpendicular to the planes. So I need to find the plane passing through 4 comma 4 comma 0. This 4 comma 4 comma 0 satisfied by this one, satisfied by this one, satisfied by this, and satisfied by this one also. But perpendicular. So whether these two are perpendicular. So here xyz coefficient positive or xy positive. So this will not be the answer. What about here? 8 minus 2 minus 6. Yes, this is possible. Just look at 12 dot product I'm looking. 12 minus 6 minus 6. So B is the answer for this question. So what I'm doing, which of the planes participating this one and perpendicular to both the planes. Are drs of this one, drs of this one, their cross product will be the directional ratios of the plane. Equation of the plane through the intersection and parallel to the line of intersection of these two planes. So when you want, drs of the normal will be 1 minus 2 minus 1. Drs of this one is 1, 1, 3. So cross product you need to write. So minus 6 plus 1 minus 5. Next, 3 minus of minus 1, 4 with the minus sign. Next, 1 plus 2, 3. So these are the drs of the normal passing through 2 comma 3 comma 1. Everything passing through 2 comma 3 comma 1, but minus 4 minus 3. So the answer is A. Answer is A. So the line parallel to the intersection of these two planes is the cross product of normals of the plane. Vector equation of the plane at a distance of 3 by root 14 from the origin and normal from the origin is this one. So simply r bar dot 2y minus 3j plus k. It should be unit vector. So divide with root 14. Is equal, what is the distance? They said 3 by root 14. So this one cancel. R bar dot 2y minus 3j plus k is equal to 3 is the answer. The perpendicular distance from that thing to the xy plane. So any point xy plane, if you are writing from here, what is the xy plane? Okay, so you need to look for the, this is the x-axis, this is the y-axis, this is the z-axis. Okay, so xy plane, point on xy plane will be 6 comma 7 comma this one. So you are going to get the distance as 8 units. Next question, reflection of the point alpha, beta, gamma on the xy plane. So if you are taking this is xy plane Here alpha, beta, gamma. So reflect foot of the perpendicular will be alpha, beta, 0. So if you take reflection will be alpha, beta minus gamma. Okay. Next one is the locus of the represented by this one. So xy plus yz. So y into x plus z is equal to 0. So this is y is equal to 0, that is xy plane, and x plus z is equal to 0. So drs of this plane will be 0 comma 1 comma 0. Drs of the normal of this plane will be 1 comma 0 comma 1. So normals are mutually perpendicular. So they are pair of perpendicular planes. Pair of perpendicular planes. XY plane divide this one in the ratio of. So what is that one? XY plane. XY plane means alpha comma beta comma 0. So when I want to take the ratio, it is known. So I'll take the Z coordinates. Minus 5 minus 0 is to 0 minus of minus 3. So this is minus 5 is to 3 externally is the answer. Next question is the distance of the point whose position vector is this one from the plane. So that is perpendicular distance from 2 comma 1 comma minus 1 to the plane x minus 2y plus 4z is equal to 4. What is the perpendicular distance formula? Modulus of 2 minus 2 minus 4 minus 4 by root over a square plus b square plus c square. It is equal to 8 by root 21 is the answer. Next question is, if 2, 3 minus 1 is the foot of the perpendicular drawn from this to a plane, then the equation of the plane is, this is the plane I need. This point is 4 comma 2 comma 1. This point is 2 comma 3 comma minus 1. What will be the dr? 4 minus 2, 2. 2 minus minus 1, 1 minus of minus 2. So the plane is 2 times of x minus 2 plus, no, it's not plus, it's a minus. Why? Because here minus 1 is there. Minus 1 into y minus 3 plus 2 into z plus 1 is equal to 0. So the equation is 2x minus y plus 2z. This value is minus 4 plus 3, minus 1 plus 2. So plus 1 is equal to 0. So they have they gave something wrong. So it is simply dr is 4 minus 2, this one. So either this one is the answer or this one is the answer. Passing to 2, 3 minus 1. If I write here 4 minus 3 minus 2. So plus 1 should be. So this is the wrong one. So B is the right answer. The ratio in which a YZ plane divides a line segment. So again the same story. So any point in this one YZ plane is 0 comma alpha comma beta. So I will take this one. Minus 2 minus 0 is to 0 minus 3. So minus 2 is to minus 3. Okay. So it is 2 is to 3 ratio. So M value will be equal to 3. M value will be equal to 3. So the next question is the ratio in which line joining this divides the plane. So this is minus pi of point A by pi of point B. In which ratio this is divided? M by N is equal to. So as per that, it is equal to minus of, you substitute this point. So 1 by 2 is, it is 2x plus 2y minus 2z minus 1 is equal to 0. So this is 4 plus 2 minus 10 minus 1 by 6 plus 8. I'm substituting this point here. Minus 6 minus 1 is equal to minus of minus 5 by this value is 7. So the ratio is 5 is to 7. The equation of the plane, intersection of plane this and this, parallel to x-axis. Parallel to x-axis. So this is pi 1 plus lambda pi 2 is equal to 0 and plane is parallel to x-axis. So that means x coefficient should be equal to 0. So you can write it as x plus y plus z minus 1 plus lambda times of 2x plus 3y minus z plus 4 is equal to. So here 1 plus 2 lambda equal to 0. So lambda is equal to minus 1 by 2. So you need to replace here with minus sign and here 2. 2x minus 2x cancel. 2y minus 3y is equal to minus 1. 2z minus of minus plus 3z minus 2 minus 4 minus 6 is equal to 0. So the answer is y minus 3z plus 6 is equal to 0. The equation of the plane through the intersection of the through the points with position vector this and parallel to this. So any plane is, this is 3x plus 4y plus 5z is passing through 1, 2, 3. You substitute here. 3 plus 8. 3 plus 8 is equal to 11. 11 plus 15, 26. So the answer is this one. Not C, it should be B. So there is a typo error here. This has to be, because plane is parallel to this one. No question of this answer. So hope you understood the questions what I discussed. Work on those questions and look at the PYQs for better score. Thank you very much. See you in the next session.